A greedy algorithm is a problem-solving approach that makes the locally optimal choice at each step with the hope of achieving a globally optimal solution. Kruskal's algorithm is a well-known greedy algorithm that finds a minimum spanning tree of a connected, undirected, weighted graph. First, we initialize an empty graph called T. Then, we sort the edges of the input graph by non-decreasing order of weight. Next, we loop through the edges, and we add the edge as long as it does not form a cycle with the edges already added to T. By the end of the algorithm, T should be a minimum spanning tree. There is almost always an important swapping step in the proof of correctness for a greedy algorithm. Let T be the graph produced by Kruskal's algorithm, and let T star be a minimum spanning tree. If T is not equal to T star, then let E be the smallest edge in T that's not in T star. Since T star is a tree, adding E would form a cycle C in T star. There is an edge F in C that is not in T, and we know that the weight of edge F is greater than or equal to the weight of edge E, because Kruskal's algorithm would have already added all edges in the cycle with smaller weight than E. Therefore, we can construct a tree T prime by swapping out edge F of T star and replacing it with edge E, and T prime is also a minimum spanning tree. Now we can repeat the process with T prime as the new minimum spanning tree. Eventually, we would be able to swap out all the edges in T prime that are not in T, and this proves that T is indeed a minimum spanning tree.